everyone, and welcome back to this Python tutorial series for beginners. And in this video we would be talking about a programmer's true horror: errors. Now errors actually are of different types. We have compiling errors, we have logical, I'll just write logic for them, and we have runtime errors. So a compile time error is an error which is thrown while a program is being compiled or interpreted. So for example, instead of writing print, you misspelled it a bit and it has just caused an error. Or there is a string which does not close, or there is a missing colon, there's an extra space. All of those errors, they go here in compile time errors. Then we have logical errors. These are errors in your logic. Let's say you made a calculator, but the answer which it returns is wrong. That is your logic which is messing up. And then we have runtime errors. Runtime error is caused when something is done incorrectly on the part of the user. Let's say you're expecting a user to not screw up, but what happens is sometimes the user does. A lot of times it does. So you're asking the user for two numbers to divide them, for example, A and B. But what the user is doing is at B, they're just entering X. And that would cause an error because X is not a number, while you would be trying to catch this into a type of a number, either float or int or anything which is associated to a number. But what the user has done is incorrect and it is causing errors. Let's say you have a very, very big application with thousands of lines of code. But if a user input can make it crash, we absolutely do not want that to happen. So what we have as an option for us as programmers is to handle those errors ourselves rather than Python crashing on us. And that is what we would be learning today: how to handle exceptions or errors. Let's first understand how an error looks like. I'll just cause an error real quick. A is equal to int input, and I'm passing nothing in the prompt because I don't want to. B, enter. So you see, this is the error. What I would do is I would just copy it right here so that everything is visible more clearly to you, and I'll make it a little bigger. Okay. So here it says trace back most recent call last. So this means that this is the line where your code basically just screwed up. And it even tells you the module which is causing the error, and it even mentions the statement which caused an error. Then here this is the type of the error, and this is the message of the error. So what it is saying is that its last callback was made to this line in line 1, which said A is equal to int input, and there was a value error which was thrown: invalid literal for int with base 10 p. So it just means that what the user entered was invalid and int cannot be converted, and the input cannot be converted to an integer. Well, this is not very user friendly to read. Let's just say that you want your error message to look a little different. You don't want the error message to entirely go away, but make it look a little different. So what you need to do is just wrap the statement that you were doing incorrectly according to Python into a try block. So just indent it using tabs or spaces, whatever you use. I don't judge you. Tabs are absolutely better. And try. So what you need to do is that inside a try block, just write try. So you're just asking Python to try this bunch of code, but if there is an error, so we're basically saying, hey, instead of crashing if this error is thrown, do something else which I say. So try, and here, let's just write the same thing again. A is equal to int input, and I'll just put tilde here. That's one of my favorite symbols ever. And we'll say except exception. So what this means is basically errors in Python are called exception. Okay, it is not mentioned here, but errors in Python are just called exception. And whenever an exception is thrown, you just want to print out user error. Clear Python 3 main dot py. Oops, main dot. Wait a second. Main dot py. Enter, and let's say I enter P. It says user error. Now let's say you also want to show the user that what is the problem that is being caused, so that they can tell the developer or get to the support team and tell them that what exactly is going wrong. Well, you would have to also show them the actual exception then, because this means absolutely nothing till now. So let's say accept exception as error, and we'll say error, and then I'll just print out the error, and if I enter P, oops, I'll have to get it into a string then. I made a type error right now. Ironic. P user error, and the error is invalid literal for int with base 10 P. So this is the error which is being thrown. Well, I think I'll just print it out like this because this would seem better. User error, invalid literal for int with base 10 P. Okay, so our errors have been handled this way. Okay, so this is technically correct, but the problem is that it's very generic. So any error which the user causes will just get printed. Now, what we can do instead is that we can set the exceptions to be specific. Instead of targeting every single exception, we can set custom exceptions for each error. So we'll say except, and this one was value error. We would say print wrong user input, or invalid. I think invalid is a better term. Invalid user input. And for, let's say, type errors, we would say print type error. So now when I run the code and I hit P, it would say invalid user input. We can also create something for keyboard interrupt. Except keyboard interrupt, print keyboard interrupt. P, oops, and I press Control C here, and it has printed keyboard interrupt. So this is how you create specific exceptions. Now, there is something that we've not learned yet, but it is important for you to understand. A lot of time we would be dealing with files or databases as programmers. Now, when you deal with them, you have to open them, and you absolutely every time need to close them, or there you can have nightmarish situations where your program completely messed up the database, and that is not something that we want to happen. An open correction is always a vulnerability, and that needs to be rectified no matter what. So where exactly do we close it? Let me give you an example. I am not going to open something here. I'll just say print opened, and after this I'll print closed. So there's a resource which is being opened here and being closed here after this specific operation. And I'll just enter something like P, and it says invalid user input. But as you can see, the resource was opened, but it was never closed. So what I can do is I can just add print closed to every single line, but that is not convenient. If I'll have to add it here and then every single line, that's not convenient at all. We do not need to do that. What we can do is we can use something which Python has given to us, and that is called finally. So finally is executed every time, even if an error is thrown or an error is not thrown. So I'll just move this line here, and if I run the code now, opened, and if I enter 1, it's closed. If I enter P, I do get an error, it's closed. Even if I give it a keyboard interrupt, it's closed. So even if I forcibly close the application, keyboard interrupt is to forcibly close a script. Even if I'm forcibly closing a script, it is still closing the database or the file, and that is absolutely important when you're dealing with data which is of high value to you. Okay, so that was all about error handling. Thank you so much for watching, and I will see you in the next one. Goodbye.